Okay, so question 1. Given that y equals 4x cubed minus 5 over x squared, find the differential in its simplest form. So step 1, we need to rewrite this equation in index form. So we're going to have 4x cubed minus 5x to the negative 2. Okay, so for part A, we're going to find the differential, which is dy by dx. 4 times 3 is 12. And then bring the power down becomes x squared. Minus 5 times minus 2 is positive 10. X minus 2 take away 1 is negative 3. And we can leave it just like that. Then part B, we're going to be integrating this equation with respect to x. So increase the power by 1, 4, and divide by the new power. 4 divided by 4 is 1, so we can leave it like this. X to the power of minus 2, increase the power by 1, minus 1, divide by the new power. Minus 5 divided by minus 1 is positive 5, and then we have to remember plus c. So 6-mark question that we've managed to do in less than 2 minutes. Okay, so for the first part of question 2, we have 3 to the negative 1.5 equals a multiplied by root 3. Now we know that root 3 is in fact 3 to the power of a half. So we have to think to ourselves, this is 3 to the minus 1.5. Okay. And then we have something times 3 to the half. So we know 3 to the power of something times 3 to the power of a half, they need to add to give me minus a half. So this must be, what number plus a half gives me negative a half? It's negative 2. So this must be 3 to the power of negative 2, which we know is 1 over 3 squared, which is 1 over 9. And then part B wants us to simplify fully this. So I'm going to do the numerator. So I have 2x to the power of a half cubed. So 2 cubed is 8. X to the power of a half cubed is x to the 3 over 2 divided by 4x squared. 8 divided by 4 is 2. X to the power of 3 over 2 divided by x squared, we take away, is going to be to the negative a half. So you could write that as 2 over root x if you wanted. Either or. So, simultaneous equations. It's better to put one into like a y equals or an x equals. We can see it's easier to rearrange the first question. So y equals negative 4x minus 1, and I'm going to substitute that into the second equation. So everywhere there's a y, I'm going to substitute in negative 4x minus 1. So I'm going to have minus 4x minus 1 squared plus 5x squared plus 2x equals 0. This is going to give me 16x squared plus 8x plus 1 plus 5x squared plus 2x equals 0 once I expanded this one out. Now I'm going to collect like terms. So I have 21x squared plus 10x plus 1 equals 0. So this gives me negative 1 over 7 and x equals a negative a third. I'm then going to substitute that back into here to find my values for y. So when x equals negative a seventh, y equals minus 4 lots of negative 1 over 7 minus 1, which is negative 3 over 7. And then when x equals negative a third, y equals negative 4 lots of a third minus 1, So y equals negative 1 over 3. So the straight line with the equation y equals 4x plus c, where c is a constant, is tangent to the curve with the equation y equals 2x squared plus 8x. If it's tangent, that means there is one intersection. So that means my b squared minus 4ac must equal 0. So to start off with, I'm going to equate them to each other. So 2x squared plus 8x plus 3 equals 4x plus c. So 2x squared plus 8x minus 4x is 4x plus 3 minus c equals 0. So now if I do my b squared, I know my a is 2, my b is 4, and my c is 3 minus c. So b squared minus 4 lots of a, lots of c, this must equal 0. So 16 minus 8 lots of 3 minus c equals 0. 16 minus 24 plus 8c equals 0. So that must mean that minus 8 plus 8c equals 0. 8c equals 8, so c equals 1. Okay, so for question 5, we have to do a sketch of a quadratic and a straight line showing all the coordinates of all the points at which each graph crosses the coordinate axes. So, I need to make sure I draw a nice straight coordinate axes. I can get my ruler out. And okay, perfect. So, I know this is my x and my y. Even though this is a sketch, I need to use a ruler and a pencil. So for y equals x plus 2, I know that this y-intercept's at 2 and my gradient is 1. So my straight line is going to be at a 45-degree angle, and it's going to cross at 2. So this is, we know this is 2. How do we find out where this is? Well, I know that on this line y equals 0. If y equals 0, 0 equals x plus 2, so x must equal negative 2. So we know this is 0, 2, and this one is negative 2 and 0. So I've done all the coordinates for that one. For my next graph, I have y equals x squared minus x minus 6. I'm going to factorize this, x minus 3 and x plus 2. So I know that my solutions are x equals 3 and x equals negative 2. So it crosses here as well, and at 3. Okay, and also my y-intercept is negative 6. So I'm now going to sketch. There we go. So I know that this is 0, negative 6. This is still 2 minus 0. And this is 3 and 0. Now, it just wants the coordinates of all the points at which each graph crosses the coordinate axes. So there's these two lines. It didn't ask for where they intersect. It didn't ask for the maximum or minimum. So you'll be okay just doing these. Part B says, on your sketch, show by shading the region defined by the inequalities. So for the first one, we want to know where is the y is less than x plus 2. So where is our y coordinates less than this equation is below the line. Okay, and we can do that by actually putting in a dot and seeing if it's true. 0, 0 is our coordinate. If I put 0 here and 0 here, is 0 less than 0 plus 2, which is 2? Yes. So it's everything below the line is what we want. Brilliant. Then for the next one, we want where is y greater than this. So again, we could try and we're either going to have inside the quadratic, or we can have outside, okay? When we have a straight line, we have above the line or below the line. So we can put in our 0, 0 value and see where. So 0 is greater than 0 minus 6. Yes, that's true. So we actually want what's inside our curve. There we go. So, where do they in fact both cross? It's that section in the middle. So that's what our region is. It then says hence or otherwise. Okay, hence or otherwise. Find the set of values of x for which this is less than 0. Now, what you'll notice is that if I equate these two, I'm going to get this. So I could even write that. So x squared minus x minus 6, where is that less than x plus 2? X squared minus x from both sides, I'm going to get minus 2x minus 2 from both sides, minus 8. Where is this less than 0? So this is less than 0. What does that mean? So instead, the reason why they've done hence is because they want you to realise that then this should be in between 2 points. But we already know that when we have a quadratic and it's positive and it's less than 0, it's always in between the 2 points because this is where the graph is less than 0. So if we factorise this, we're going to get minus 4 plus 2. So x equals 4 is less than x is less than minus 2, which is where it is less than 0. And it's just reaffirming this. Question 6. Okay, so figure 1 shows a sketch of the curve C with the equation y equals f of x. The curve passes through the origin, so there's a point 0, 0, and through 6, 0, and it has a minimum at 3 minus 1, which is already labelled on the graph. On separate diagrams, sketch the curve of the equation y equals f of 2x. So, f of 2x, is it inside or outside the bracket? Inside, so it affects x, and we're going to half all of the x coordinates. Okay? So, when I'm sketching this using a ruler and a pencil, I can draw the exact same sketch, and then all I need to do is half all the x coordinates. There we go. Right, so A is quite easy. Part B says y equals f of x plus p, where p is a constant between 0 is less than p is less than 3. On each diagram, show the coordinates of any points where the curve intersects the x-axis and of any minimum or maximum points. So if we're sketching this, we know that 0 is less than p is less than 3. If, for example, we were to put f of x plus p plus 3, we know that it's inside the bracket, affects x, we would take away 3. So this minimum point would now be here. So however we now draw this, we know that this needs to be in between the y axes here. So in between here If you draw this with this part on the y-axis and we label it correctly, that will be perfect. So here's my x and y. I'm just going to shift it slightly. Okay. So my coordinates are now going to be, all of my x coordinates have a p taken away. So this is going to be 0 minus p bracket 0. This is 3 minus p bracket negative 1. And then 6 minus p bracket 0. And there we go. We've written everything down and the graph still looks right. If you put your minimum point on the line or on the left-hand side, you will not get the full marks. Okay, so question 7. A curve with equation y equals f of x passes through the point 425. Given that the differential of x equals this, find f of x. So we know we're going to have to integrate. Now, lucky for us, everything is in index form. So we're going to go straight to integrating 3 over 8x squared minus 10x to the negative half plus 1 with respect to x. So increase the power by 1 cubed and then divide by the new power. So 3 over 8 divided by 3 is 1 over 8. Then increase the power by 1 is positive a half, divide by the new power. Negative 10 divided by positive a half is negative 20. And then increase the power by 1. And then our favourite thing that we have to write at the end, plus c. So, now that we've done that, we've been given a point. So we're able to substitute this point in. We know y equals 25 when x equals 4. So everywhere there's an x, I'm going to substitute in 4. And this will allow us to find our value of c. So I'm literally going to type this into my calculator. 1 over 8 times 4 cubed minus 20 times 4 to the power of a half plus 4 is equals negative 28. So I get 25 equals negative 28 plus c. So if I add 28 to 25, I get 53. So c equals 53. Therefore, the equation f of x equals 1 over 8 x cubed minus 20x to the power of a half plus x plus 53. Okay, so question 8. The line L1 shown in figure 2 has equation 2x plus 3y equals 26. The line L2 passes through the origin and is perpendicular to L1. So that means that they do meet at a right angle, and because they're perpendicular, and also that the gradient of L2 is the negative reciprocal of L1. Find an equation for L2. So first of all, we need to rearrange L1 to find the gradient. So 2x plus 3y equals 26. 3y equals negative 2x plus 26. Y equals negative 2 over 3x plus 26 over 3. So the gradient of L2 is then going to be the negative reciprocal of negative 2 over 3, which is positive 3 over 2. We know it also passes through the point 0, 0. So using y equals mx plus c, 0 equals 3 over 2, lots of 0 plus c. I just realised I'm on autopilot. Of course, my y-intercept is 0. So my c is 0. So the equation of L2 is y equals 3 over 2x. Okay. So there we have 4 marks, nice and easy. The next says the line L2 intersects the line L1 at the point C and crosses the y-axis at the point B. Find the area of the triangle OBC, given your answer in the form A over B, where A and B are integers to be found. So OBC, first of all, which triangle is this one? It's this one here. Okay, so there's two ways to find the area of the triangle. We know this is a right angle triangle, so there's two different methods here. Method number one, you could find the base and the height, base times height, and divide it by 2. Okay? Method number two, you could use this as the base and this as the perpendicular height. And then divide that by 2, obviously, because we're dealing with a triangle. Now, this one is actually going to be simpler to do this way round because we only need to find the coordinates of B and C, and then we know this is from 0 to B, just the y coordinate, and then is the base essentially. And this height is just the x coordinate of C. If we were to do it this way, we'd have to find the coordinate of C, and then we'd have to use Pythagoras to then find the length of B. So I'm going to go with method 2, even though both methods are correct. So let's find out where they intersect to find C. So I know I need to put them equal to each other. So 3 over 2x equals minus 2 over 3x plus 26 over 3. So if I add 2 over 3 to both sides, 3 over 2 plus 2 over 3x is going to give me 13 over 6x equals 26 over 3. And then I'm going to divide both sides by 13 over 6. 26 over 3 divided by the answer is 4. So my x coordinate is 4. And my y coordinate I don't actually need to work out, but if I wanted to, I can just substitute it into here. 3 over 2 times 4, which is 6. Now my b coordinate here is where the line L1 crosses the y-axis. If it crosses the y-axis, x is 0. So where is x is 0? And that is when y equals 26 over 3. Because imagine if this is 0, 3y is 26, so y equals 26 over 3. So this is 0, 26 over 3. So then, this length is 26 over 3. And this length is 4. So 26 over 3 times 4, all divided by 2, is going to give me the area of the triangle. Which is 52 over 3 units squared. It wants it in the form of a fraction. Brilliant. So 52 over 3 units squared. Question 9 then. So question 9, a sketch of part of the curve of the equation y equals 20 minus 4x minus 18 over x is shown in figure 3. Point A lies on C and has x coordinate equal to 2. Okay, so I'm going to write that on there. 2 something. Show that the equation of the normal to C at A is y equals minus 2x plus 7. Okay, so if we know this equation is 2, we want to find the normal. First of all, we've got to find the tangent. Okay, the gradient of the tangent. So then we'll be able to find the normal. So I'm going to substitute in 2 into the equation of y to find our y coordinate. 20 minus 4 times 2 minus 18 over 2. It's going to give me 3. Okay, so how do I find the gradient at this point? The gradient function, I need to differentiate. First of all, I need to put this in index form. So y equals 20 minus 4x minus 18x to the negative 1. If I differentiate this, 20 differentiates to nothing, minus 4x differentiates to minus 4, minus 18x to the negative 1 is plus 18x to the negative 2. I'm now going to substitute in the value of 2 to find the gradient. So minus 4 plus 18 times 2 to the power of negative 2 is a half. So the gradient is a half of the tangent. That means the gradient of the normal is the negative reciprocal, which is minus 2. I have my y-coordinate, I have a gradient, and now I have a pair of coordinates, which is 2, 3. I'm going to use y equals mx plus c. So 3 equals minus 2 lots of 2 plus c. So 7 equals c. Therefore, y equals minus 2x plus 7. So we've proved that now. Okay, the next part of the question says, the normal to C at A, so this line here, meets again at B, as we can see. And we've just worked out the equation of this line as y equals minus 2x plus 7. Use algebra to find the coordinates of B. So I need to put them equal to each other. So I'm going to have 20 minus 4x minus 18 over x equals minus 2x plus 7. Okay, I'm going to move everything to the left-hand side. So 20 minus 7 is 14. Minus 4x plus 2 is minus 2x. Minus 18 over x equals 0. Okay, so now I have a hidden quadratic. I need to multiply everything by x. So I'm going to have 14x minus 2x squared, and then minus 18 over x times x is just minus 18. This equals 0. I can now use my calculator to factorise this for me. So my a is a negative 2, because that's the coefficient in front of the x squared. 14, and then negative 18. So I'm going to get my x1 is 7 plus root 13 over 2, or 7 minus root 13 over 2.
How did you get 14x? Surely when the b 13.
Yeah, you're so right. What a mistake. Right, what is 20 minus 7, everyone? 13. Oh. That's why I need a calculator today. My head's not in it. Okay then, so in this case, my b is, this will hopefully give us nicer numbers. Ah, it does. So x1 is 9 over 2, and x2 is equal to 2. Now we already know that x2 equals 2 because that's this coordinate here. So my coordinate of b must be 9 over 2. And then how do I find my y? I can substitute it back into the equation of the straight line or the equation of the curve, either or. I'm going to use the equation of the straight line, minus 2 lots of 9 over 2 plus 7. Now I get minus 2, but I'm just going to double check on my calculator. Minus 2 times 9 over 2 plus 7. Yeah, minus 2. So that means my coordinates are 9 over 2 and negative 2. Now, you need to make sure this makes sense. And we would have checked, I would have spotted that I would have had a mistake here earlier because one of my coordinates wouldn't have been 2. Okay? And what you notice here as well is, I know these diagrams are never drawn accurately, but here you can clearly see that our y coordinate will have to be negative. So you can see this does make sense. So nice and easy, 11 marks. Okay, so question 10. The triangle XYZ in figure 4 has XY6, YZ9, ZX4, and angle alpha. The point W lies on the line XY. The circular arc ZW is a major arc of the circle with centre X and radius 4. Show that three significant figures, alpha is 2.2. Okay. So think about this, we have a triangle, we have three sides and we want to work out, so I'm going to use cosine rule. So cos A equals A squared minus B squared minus C squared divided by negative 2 lots of B, C. Okay, I'm going to make sure my calculator's in radians. Okay, so I then got cos of A equals negative 6 naught 4 dot dot dot. So shift cos answer, so that I keep it exact. It's 2.2195, which rounded to 2 decimal places is 2.22. Now it says find the area in centimetres squared of the major sector. So the area of the major sector is this here. So we know angles in a circle of 360 degrees, aka 2 pi. So to find this angle, I need to do 2 pi minus 2.2. And area of a sector is theta over 2 pi times pi r squared. So theta over 2r squared. So our theta is 2 pi minus 2.22. Divide that by 2, multiplied by our radius, which is 4 squared. So shift pi times 2. So I get the area is 32.51. It doesn't say what we have to round it to, does it? Okay, centimetres squared. I've done 2 decimal places. The next part says that the figure is used to be designed for a logo. Calculate the area of the logo. Well, we've already calculated the area of the major sector, so we just need to add on the area of the triangle. Now we know area of a triangle is a half AB sine C. So I'm going to do 32.51 plus a half lots of 4 lots of 6 sine of 2.22. I'm literally just going to write that whole thing into my calculator. 32.51 plus half 4 times 6 times sine of 2.22. 42.07.
Yeah.
Perfect. Okay then.
Is it fine if I round it up to 42.1?
Yes, it hasn't said for what we're doing. Okay, and then the next it wants the perimeter of the logo. So I always like to do this step by step. I'm going to do what I know first. I'm going to trace around the outside. So we know that's 9 plus a different colour. This WY. Now, if we know this whole length is 6 and the radius is 4, then WY must be 2. And then plus, and I need the arc length of the major sector ZW. Now, I know that that's theta over 2 pi times 2 pi r. The pi's and the 2 cancel, so it's just theta r. Now, remember, our theta is 2 pi minus 2.22 multiplied by my radius, which is 4. Now, I'm going to put that whole thing into my calculator, and you can see how I've broken it up. 9 plus 2 plus bracket shift pi times 2 minus 2.22 times 4. 27.25. 0.25 centimetres. And there we have it.